Okay, we go for the next application called Venturi meter. So Venturi meter is actually same with the idea of pitot static tube or the orifice meter. However, the Venturi meter will give us an incline changes of cross-sectional area. Okay, why we need to change the cross-sectional area here? Because from the continuity equation, A1 V1 it is equal to A2 V2. So it is mean that if the cross-sectional area is not changed, the velocity is remain constant. So if the velocity is constant, means the velocity is not changed, the pressure is not changed. So if pressure is not changed, so means that we cannot use the Bernoulli equation to calculate the pressure, to calculate the velocity. Then if we cannot get the velocity, we cannot calculate the flow rate. Okay. So and then if we compare this design, mean Venturi meter. Okay, Venturi meter has a sleek design like this one compared to the orifice meter. So orifice meter, as I said, it will have disadvantage of contraction coefficient, because the cross-sectional area that comes out from the hole is not the same with the hole on the wall. So this is give us, okay, we call it as a resistance or friction in the calculation. Okay, because it has friction, so engineer tried to create flow that didn't give any resistance. So we engineer design a Venturi meter where the inclination of this one is very smooth and it's not make any disturbance of the flow. So the idea is simple. So in Venturi meter, the smallest part here is called throat. Okay. So and then we will have a manometer on the throat to measure the pressure. So and then we will have another manometer on the other side of the pipe. So that point can be after the Venturi meter or after the throat or before the throat. So why? Because both of these area will have same diameter. So means that the pressure and the velocity after the throat and after the throat will be the same, because the diameter is the same, velocity is the same, then the pressure will be the same. So and then we could calculate the pressure here. Okay, the question is special fuel flow through the Venturi meter shown in figure 6, determine the elevation H. So we need to calculate what is the H here of the fuel in the open tube connected to the throat of the Venturi meter. So this is the open tube. So this is means that we need to take care, or we need to involve the atmospheric pressure in our equation. So this is the question. Okay, so then we need to okay, so we need to first to point out point number 1 and point number 2, and then we need to list all the parameter here. So and then I think student could imagine, we just imagine that water flow from bottom to the top like this one. So and then it will go through point number 1 and point number 2 here. So means that now because it moved in one streamline on the same streamline, so we could compare point number 1 is equal to point number 2. So at point number 1 here, so P1 so it exists, so we need, it is unknown, we need to calculate. So V1 for sure it is unknown because water flow at point number 1 here with certain velocity, and Z1 maybe we could take it is equal to 0. So Z1 is equal to 0 if we take this level is the datum. So means that point number 1 here is equal to 0 because it's on the datum. However, this point number 2 will have 24 centimeter as the height because it locates 24 centimeter above the datum. So this is for point 1 and point 2. Again, P2 it's still it has a pressure to be calculated. So and then V2 here, so we have velocity because in reality there is a velocity passing through the point number 2, and for Z here, so it is 24 centimeters because it is locate 24 centimeter above the datum. So this is the data that you need to know from that diagram. So and then normally if our diagram has manometer, so means that we could calculate the value of pressure here. So and then please be very careful. Not all the situation V1 is 0, V2 is 0 and so on. You need to list down all the parameter here. Depends on the situation, depends on your application here. Sometimes both equation has value. For example, at this situation V1 and V2 is not equal to 0. Okay. Now we could calculate the value of P1 and P2. Let's say we calculate the value of P1 first. So you could know that P1 is here. So and then it's connected with a manometer tube, and then you could calculate the pressure based on the idea of pressure that we learned previously. So it starts with the Pascal paradox line. So this is the Pascal paradox line. So means that if we have A and B here, so we could write PA is equal with PB. So and then we could say that because PB here is open to atmospheric pressure, so we could write PB now is equal to PATM. So and then for PA here, so we could write as PA is equal to rho G and H plus P1. So because at point number A here, so point A here, so we have a rho GH, so mean the pressure because there is NH liquid above it, and then pressure at point number 1 will add pressure on that point. So this is the equation, and for pressure PA here, there are no atmospheric pressure because no atmospheric pressure make contact with the liquid inside the pipe. So this is pressure for point 1. So and then we could calculate pressure at point number 2. So this is quite straightforward. So we have a point here. So we could calculate with rho GH 3 meter here plus the atmospheric pressure that push the surface. So we could assume that PATM is equal to 0 in this situation. So this is the calculation, and then we could get that P1 it is negative 0.77 rho GH, and P2 it is equal to 0.77 rho G 3 meter. So and then we could here in this situation, so we know that the water flow with 5 meter per second. So we know the velocity, we know the diameter, so we could calculate the value of Q, mean the volume flow rate can be determined. Okay, but now at point number 1 here, so we know that the velocity is increased. Why? Because the diameter is smaller compared to the diameter here. So by using the idea of A1 V1 is equal to A2 V2, so we could, if this is point number 1, so we could determine the velocity at point number 2. So when you're using the continuity equation, as it names. Nama dia pun continuity, maknanya ia bersambung. It is okay for you to compare point number 1 with point number 2 here, or point number 1 with point number 3 here, or in this situation, so it is okay for us to compare before or after the truth here. Okay, so jadi maknanya tidak menjadi kesalahan untuk awak compare sama ada nilai yang di atas atau nilai yang di bawah. So and then if you do the calculation here, you will get the velocity at throat or velocity at point number 1 is 11.25 meter per second. So and then we substitute into the Bernoulli equation all the parameter that we calculated above. So we found that h is equal to 1.936 meter.